I'll again have customer as my source table. So what we will do is here is we'll have customer as my source table, and then we will do a lookup on the orders. So I select customers over here. Hmm. Okay, and then I'll name this mapping as m underscore. Okay, and then again we have like couple of type of lookups. We have connected lookup and unconnected lookup, right? So first of all, let's see connected. So I'll just add a lookup over here. Okay, so this is connected one. And then in the properties general tab itself, I do have an option to make it as unconnected. So if I just click on this, right, then it will become unconnected one, which will break the incoming and outgoing flows. Okay, so we'll see unconnected later. Now currently I can see the incoming fields are the ones which are coming from my customer table, right? Now if I go to the lookup object, I'll select Oracle connection, and then we'll select orders table over here. So now after selecting orders table, so here I need to select the multiple match policy, how I'm going to treat this, right? So return first row, return last row, return any row, return all rows, or report error. So return first row, last row, or any row. If I use any of these properties, right, first three, then I'm defining my lookup as passive lookup. Okay, only one return value will be there. But then if I say return all rows, then my lookup is configured as active lookup. So if I get more than one matches, in that case, I can have them and process them accordingly. Here in this scenario, we have customer as a source table and order as a lookup table. One customer can have more than one orders, right? So in that case, it makes sense to have written all rows. Okay, so for one customer, if we have like more than one orders, then those orders can be processed further. Okay, then if I go to advanced, I do have tracing levels, I do have SQL lookup SQL override, right? So lookup SQL override is used whenever we need to be choosy about which fields we need to select from the lookup, right? I may have a very large table, right, in the lookup. So lookup table might be like really large. I may have like lot of columns, or like that table might have grown vertically and horizontally, right? In that case, if I know that I want to match the condition of a particular field and get the other field or few fields, in that case, why to allow Informatica to do like full table scan? So if, say for example, I do have a country ID coming in my source table, right, and I do want to look up on the country master table, match the ID and get the country name. Okay, but if that table is having a lot of other columns like continent and all, right, or geographical location, latitude, longitude, and all, right, so we're not interested. We just need to pass the country ID and get the country name. In that case, I can write a SQL override query, select country ID comma country name from country master, by which I'll be limiting how many columns I want to fetch from the lookup table, and then that will expedite my performance. One use is this, right, of lookup SQL override. Second use could be if I am matching, or if the lookup condition is based on the string fields. If it is numeric field like matching country ID or customer ID to customer ID, we don't have any issues, right? But whenever I'm doing a lookup by matching a string field, right, in that case it makes sense to convert that field to upper or lower and then compare it. So in that case, we can also write a query, select upper of something something comma upper of something something, right? So that way if I want to do that kind of a conversion, right, string to be converted to upper, right, so that time also we can use this SQL override query. Okay. Then lookup source filter also can be applied if I have like very large data set, right, lot of rows I have, and then I'm very sure that I'm going to do a lookup, or I have to do lookup on a specific set of the data, right? Maybe if I have a lookup table in which I do have data related to multiple countries, India, US, UK, Russia, right, all, and then I know that the data set which I'm going to do a lookup on needs to be only where country is equal to India. So that kind of a filter, lookup source filter, can be applied over here, so that again unnecessary rows will not be scanned in the lookup table, and then my performance will be expected. Because whenever it comes to lookup, right, we are always keen about the performance, and whatever is the best performance possible by setting up properties, right, we'll go for it. Okay, so that is how we have SQL over also lookup SQL override, and then lookup source filter. If I scroll down, then I will find the caching options, right? By default, lookup cache is enabled. Now, what is lookup cache? You must be already knowing it. I'll just repeat that. So whenever I have a lookup transformation, right, then while running the mapping, Informatica will check whether mapping is sorry whether cache is enabled. If caching is enabled, then before the mapping starts executing, that whole table, right, that lookup table will be, the data from that lookup table will be cached into the cache memory, right? And whenever I'm running the mapping and doing the lookup, right, rather than hitting the database, right, or hitting that table in the database, I'll just refer my cache memory, and that will again improve my performance. So by default, whenever I enable the cache, it will be a static cache. Right? So there are like three caches: static cache, dynamic cache, and the persistent cache. Static cache is one whenever I run a mapping, right? Before executing the mapping, Informatica will identify there is a lookup transformation used in this particular mapping. It is caching enabled, and by default, it is a static cache. So what will happen every time I run the mapping, right? First of all, cache will be built, right? So we will pull the data from lookup table in the database, right? And then that data will be stored in my cache memory. Whenever I complete that mapping, my cache will be cleared, right? And again, whenever I'm running my mapping second time, third time, every time in the initial stage of my mapping execution, my cache will be built. Okay, so that is what the static cache is. Now, one thing about static cache is like it will not change during the execution, right? So say for example, if I'm doing a lookup on my target table itself, right, to do some existence check, or if I want to take a call whether a source record needs to be marked as insert, update, upsert, or delete, right, that time I need to do a lookup on the target table itself, check whether that key matches, right, primary key or that column matches, and then accordingly I can take a call to flag the record. So this kind of lookup is called as a existence check, right? We are doing lookup on the target table itself. Over here, say for example, in the mapping execution, if I'm pushing some data to my target, right? So that extra data or new data which we have pushed in the target during the mapping execution, right? That data will not be loaded to my cache memory if I'm using the static cache. right? If I'm using a dynamic cache, then whatever data goes in my target table, right, same data will go to my cache memory also, right? So dynamically we are updating the cache, right? But then dynamic cache is like really costly element in ETL development, right? Why? Because it will hamper the performance like anything. So we need to see, right, whether the dynamic cache is really required or not, right? A lot of time what will happen is like, if we have duplicates and then I put that question to a lot of people, right? Have you ever used dynamic cache? People will say yes. And then why we used it? Because I had duplicates in my source, and then I wanted to see whether a particular record during the mapping execution, have you pushed it to target, right? And then for that I used a dynamic cache. So I would always say that if that is the case, right, that you have duplicates in your source and for which you are going to use a dynamic cache, why don't you deduplicate your data in the source and use still static cache? And people will be clueless. Oh yeah, that can be done. So it is a bookish, or I would say, what I would say, just they must have read somewhere that okay, whenever I have duplicates in my source, then it becomes very important to use the dynamic cache, which is not true, right? There has to be certain scenario where dynamic cache is really required, right? That time only I can use it. Otherwise I will try to avoid as much as possible, right? Because the cache, right, dynamic cache wala mapping will definitely going to take lot of time. It depends upon also how much data volume we are pulling, right, from the source, and how much data that lookup table is already having. So all those things will come into the picture, right? So that is what the dynamic cache is, which will get updated during the or refreshed during the execution itself, right? Third type of cache is the persistent cache. Okay, persistent cache is one, whenever I'm running that mapping having persistent cache for very first time, my cache will be built. Okay, and then from second time onwards my cache will not get refreshed. So persistent cache is used for such tables which doesn't undergo changes, much changes I will say. For example, again, if I have a table called country master, okay, so every time what I need to do is like I need to pass the country ID and then match it, get the country name every time. Now no list of countries in that table won't change unless there is a third world war and we have like more separations, right? List of countries will remain same. So why to use kind of static cache and pull the same information all over again, right? So these tables, whenever we have lookups to applied on, right, we can definitely go for persistent caching. Okay, so these are three main types of caches we have. These are similar to what Power Center also. It's exactly similar. There is no difference. So by default, the lookup cache will be enabled, right? And then that will be static cache. If I want to make it as persistent cache or dynamic cache, right, I can use them accordingly. Okay. Now if I go to the lookup condition, before I do that, right? So now see, lookup condition has given me conflict because initially I just took this particular transformation after selecting what is going to be my lookup object, right? Whenever I selected orders, right, in the incoming field also I'll see this issue, right? Why? Because customer ID is again common across the source table and the lookup table, right? So again what I can do is resolve field name conflict. Now here we need to add a prefix only for the source data. So I'll just use prefix. I'll say src underscore, and then all the fields which are coming from my source table are renamed to src underscore field names. I have added this prefix. Now if I go to the lookup condition, now the things are sorted. It says that some fields were renamed. So now I can go for a simple condition or completely parameterized, right? So simple condition, I'll click on this plus sign. I'll say customer ID 2, customer ID. Again, we have decimal double over here. I can change the edit, I can do the edit metadata by going to source, make it, you know, double double, and then accordingly we can no, sorry, decimal decimal, we can do that, and then we can match it. So I will rule out any other possibility of, you know, non-matching data types, right? And any consequences, I can handle that. If I go to the written fields, these are the fields which we have, right? As we know that connected lookup will be able to take all the columns, right? As a response, as a return, right? In case of unconnected lookup, we can only have one column. Here we have seen all the columns, right? But then if I don't want to have like specific columns to go forward, right, from the lookup table, I can just simply select them and delete them like that. For now, I'll keep everything, right? And then again, advanced will show me the similar properties, the caching and all, right? So these are the similar properties I can see against the advanced as well. So this is how I have configured my connected lookup. Okay. If I want to make it as unconnected, right, then what I need to do is I'll define this as unconnected in the general tab. It will give me warning that upstream downstream connections linkage will be broken. If I say yes, now it is broken. So unconnected lookup can be called from an expression transformation. So I'll have expression. Okay. Now, one thing which we need to change in the lookup transformation is incoming fields, right? I don't have any incoming fields now because it is unconnected, right? So I will create the fields manually in the lookup transformation, right? Which fields? Those which we are going to use in the lookup condition. So here I'll create a field. I'll say um, input customer ID. Lookup condition I'll have to mention as customer ID to input customer ID. Here the data type is undefined, right? Undefined as in like it is just a field we have, you know, defined or created, right? So whatever is the data type from incoming, it will be flexible enough to handle it. So I don't have to define any particular data type. If string comes in, the comparison will happen like that. If numeric comes in, accordingly comparison will happen, right? And then if I go to the expression tab, so if I want to pull by passing customer ID, if I want to pull order ID, right? So I'll create that field. I'll say LKP order ID is gonna be decimal. Click OK, and then I will configure it. So I can write my own syntax, or again I can go to built-in functions, scroll to the down, and then I do have a lookup over here. If I click on U lookup, unconnected lookup, then this is what my syntax for calling the lookup, right? And then what I need to do is like again go to fields, in place of input customer ID, right? I'll just provide the customer ID over here. So colon lkp dot lookup transformation name, and then the arguments which we need to pass, right? If I have like more than one columns on which I want to have a condition, those columns must be defined, right, in the incoming fields tab of unconnected lookup, and those many things, those many fields can be initialized, right, from the fields which are incoming. If I validate this, my lookup is valid, the lookup call is valid. Okay. Now whenever I change this, right, to unconnected, then let's see what are the other things we need to notice over here. So if I go to the written fields now, I need to choose which is gonna be my written field. Unconnected lookup can give me only one field as written, right? So if I'm just matching the customer ID to customer ID and taking the order id out, right? Then I will have to select order id as a return field. Okay. And also if I go to lookup object, multiple matches policy I need to set, but then as it is a unconnected lookup, I can't configure it as a active lookup. It has to be passive, right? Multiple matches, right? That kind of option, right? Return all rows. That option we don't have for unconnected lookup. So unconnected lookup can be only configured as a passive transformation. Not all the matches can be taken ahead. Okay, so I'll say return any row, and then other thing, if I go to the advanced, I can enable the static cache or persistent cache, but not the dynamic caches. Again, there is a limitation of unconnected lookup. It can't be configured as a dynamic lookup. Dynamic cache can't be used with the unconnected lookup. So we have these many limitations, right? We can't use dynamic cache. We can't use, multiple matches. We can't configure this as active lookup, right? We can only have one return field, right? So if we have these limitations, right, then why to even go for unconnected lookup? What is the advantage of using unconnected lookup over connected? Very basic or common interview question. So unconnected lookup is used whenever I want to perform lookup on that same table multiple times in my mapping, right? So I can define it only once, right? And then I can keep on calling that lookup as a function whenever I require. Okay, so this is what the lookup transformation is.